During a week, Speedway has 12 flights from city A to city B. Let me take one new page for this problem. During a week, Speedway has 12 flights from city A to city B. The time taken for any flight is independent of the time taken by any other flight. Calculate the probability that at least 7 of these flights are on time. So this is the binomial distribution. So I will cover this using y1 for the first problem and second problem y2. This is binomial distribution bin 12 comma the probability is 0.830. From the previous problem we know that the complete probability is it will be 0.830. It is stated in the question, that is the flight is on time, the probability is 0.830. So I have taken that probability value, and the expression of this particular binomial distribution will be y1 equals to binomial distribution of 12, that is n equals to 12 and p equals to 0.830. Okay, so let's again start this. So here as I have told, n equals to 12 and p equals to 0.830. So then expectation e of x, this is equals to np, and v of x, this is equals to np into 1 minus p, or we can tell that npq. This is the variance, and standard deviation is root over npq. These all are the things that we can know from the binomial distribution. Now what we need to find out is that calculate the probability that at least 7 of these flights are on time. 7 of these flights are on time. So how you will calculate that? The formula is p of x equals to r, where r is the number, p of x equals to r. I am giving all the things in one space, that is ncr into p to the power r into 1 minus p to the power n minus r. So this is the value, p x equals to r, ncr pr 1 minus p to the power n minus r. Now what all the number of trails, number of t trails is equals to n, then number of success, this is equals to r, number of success, and probability of a single trail, equals to p. So here n is 12, r is 7 for this example. For p, x equals to 7, r is 7, and probability is 0.830. It is given. Now you can calculate this from this equation. You have calculator in your hand, but I will give you one graphical representation on this problem. So let's see the graphical representation first. Okay, so from the graphical representation, it is like the number of it is 12, then probability is 0.830, and x is 7. So as you can see, the probability of x equals to 7 is just you can see that where the probability of 6 is 0.00729, probability of 7 is 0.031. So from 7 it is starting. This is the importance of this graph. This the you can also manually calculate this also, but this is the importance. So it is a this is a graph from one university, and it is a very good graph. Now you can see that calculate the probability that at least 7 of these flights are on time. So at least we need 7 of the flights to get a particular probability value, that is 0.037. So in this way, from 7 it is starting. So that's why the graph value is there. So in this way you can understand that it is proved that. Now given that at least 7 of these flights are on time, find the probability that exactly 10 flights are on time. So again you can do that, exactly 10 flights. So it will be p of x equals to 10. You need to find out p of x equals to 10 from this formula again, but I will give you the graphical representation. So again see the graph. This is the graph, and at p x equals to 10, p probability x equals to 10, you can see the highest bar, that is 0.29595, and after the 10th bar, that is p of x equals to 10, the graph is decreased, the value of the bar is decreased, again the value of bar is decreased. So at this particular point, at p of x equals to 10, it will reach the highest probability. So again from here you can tell from the graph I have also given you the solution. Given that at least 7 of these flights are on time, find the probability that exactly 10 flights are on time. So what we need to calculate, 10 flights on time, it means the probability will be this, that is 0.29595, and we need to calculate all the probabilities previously. So that's why this probability will be calculated and it is expressed. You just have to put this formula in the calculator that you have, TICX calculator, and it will be easier for you to calculate. Okay, as I don't have the calculator, and for this huge equation online calculators are also not available, so I have given you the graphical representation. This is the graphical representation, and obviously you can get the normal value. Also you can see the values here. This is the link, you can see the values here, and in this way you will be able to. And again, if I can change it to be 10, now you will see that the value was there. Now I am changing this to 10. And one more thing, I just need to give you one more example. The number of cases are 12. Number of cases are 12. X is equals to 10. The trial is say 10, and probability is 0.830. So this is the probability, and as you can see, this is 0.296 as 10 at 10, and all others are decreasing. Okay, so you need to calculate all this before you need the actual value. So you can calculate that from calculator, so that's why I'm leaving that part. Okay.